All right, so in this video, we are finding the inverse function. So we're not given a function and another function and asked to prove. We're actually given a single function and said we're asked to show that it has an inverse and then find said inverse. So I'll talk about the steps on how to do that here in a minute. So what we're going to do is first, to prove that a function has an inverse, it must first pass the horizontal line test. So I have already plotted the first function, right? 3x minus 2. It's just a nice line. Again, we can put in y equals equations here. And you see that horizontal lines are only going to touch this guy at one point. And so he does, in fact, pass the horizontal line test. All right, so if that's the case, then our next thing is to go ahead and find the inverse. How do we do that? Well, to do that, we need to first replace the function f of x with y. So step one, y equals 3x minus 2. Step two, interchange the variables x and y and solve for y. So what I really mean by that is everywhere you see a y, replace with an x. Everywhere you see an x, replace with a y. So this equation becomes x equals 3y minus 2. Now it says go ahead and solve for y. So to get y by itself, I need to add 2 to both sides. Then I need to divide by 3 everywhere. So I get y equals x plus 2 divided by 3. Alternatively, you could write this like this, or even like this if you wanted. I'm just going to stick with this first one for now. And actually, let me not box that guy because we're not quite done. The last step says replace y with the symbol f inverse. So to finish, f inverse of x is x plus 2 over 3. All right, the last part is to verify that what we have found is indeed the inverse function. So to do that, remember, we just need to plug the original function into the inverse. So we're going to do f inverse of f of x. That's going to be 3x minus 2 plus 2 divided by 3. The minus 2 and plus 2 cancel, and we get 3x over 3. All right, 3 over 3 cancels, and we just get x. We also would need to do f of f inverse. And so that's going to be 3 times x plus 2 divided by 3 minus 2. 3 over 3 cancels there. Then we get x plus 2 minus 2. And that yet again just gives us x. So everything looks good there. All right, let's take a look at another example. We have x to the 5th plus 7. Again, I'm going to hop over to Desmos. All right, again, I've already plotted this guy. Here's x to the 5th plus 7. Again, if you draw horizontal lines here, right, again, and if you zoom in really, really far here, right, this will not touch in more than one place, okay? It's just the numbers are so small that we can't really see it. So I can zoom in all day and it looks like it's going to touch, but we're okay there. All right. So hop back over. X to the 5th plus 7. So I need to find the inverse. So I let it equal y first. That's step 1. Step 2 is interchange x and y's. So x equals y to the 5th plus 7. And then we need to solve for y. So I would subtract 7. So I get x minus 7 equals y to the 5th. Then to get rid of to the 5th power, what I need to do is take the 5th root. So 5th root of x minus 7 is equal to y. All right. Then last step is to change y into f inverse. And an alternate way to write this, if you'd rather, is x minus 7 to the 1/5 power. Okay, either of those will work. And then, of course, we have to prove that we found the inverse, so we need to plug. Actually, sorry, since this is g, let's call this properly g inverse, right? All right, so we need to do g of g inverse. So that's going to be, and I'm going to write it this way. Maybe this will help you. So x minus 7 to the 1/5 power, all to the 5th plus 7. So 5th power and 1/5 power undo one another, right? You multiply those exponents, and 1/5 times 5 is just 1. So we have x minus 7 plus 7. And once again, we just get x. Lastly, we need to do g inverse of g. So we're going to do g inverse of g of x. That's going to be plugging in g of x. So that's x to the 5th plus 7 minus 7. So this one's a little easier, I think. Plus 7 minus 7. Then you have the 5th root of x to the 5th. That's just going to be x. Okay, so indeed we found the inverse. So I'm going to leave it to you to go ahead and compute that part for these next couple. I'm just going to focus on finding the inverse. So I have x squared plus 1. Once again, let's take a look at the graph. We should know basically what that looks like, right? That's going to be a parabola, like the parent function's x squared. It's plus 1, so it's shifted up 1 unit, right? Kind of combining some of the stuff we've been learning thus far. If we were to draw a horizontal line, what happens? And if I let y equal 2, for instance, well, I get that I touch the curve in 2 places. So this does not pass the horizontal line test. So we're going to say no inverse. However, if the domain was restricted, if the domain was from 0 to infinity, meaning just this portion of the curve, then that would indeed have an inverse. And let's see if I can do this property. It should look like that. All right. I think this is the last example here. So x to the 5/3 minus 3. Remember, step 1 is to let it be y equals. Second step is to interchange all of the x's and y's. So everywhere you see a y, make it an x. Everywhere you see an x, make it a y. Then we need to solve for y. So I'm going to add 3. How do I undo a power of 5/3? Well, if I have y to the 5/3 and I raise it to the power 3/5, what happens? Well, I'm multiplying those 2 powers together. So I have 5/3 times 3/5, and all of that is going to reduce down to 1, which is just y. So I need to raise both sides of this equation to the 3/5. And so I get y equals x plus 3 to the 3/5 power. Last thing is to make it an inverse. Our function was called I before. So I'm going to call this I inverse of x. And that's x plus 3 to the 3/5. Again, you're going to want to plug I into I inverse and I inverse into I and prove that that works. I did forget to jump over and look at the graph, so we can do that quickly. All right, so the graph is here. This function clearly passes the horizontal line test, and therefore it does have an inverse, which we should have done to start, because that tells us to continue. All right.